David Smith here with another Flip Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit your ability to consume the video. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's topic, B's unit review. And as I'm sure you remember, we've been working through a unit in our blue book called Do B's Build It Best? And we've been exploring a lot of geometry along the way to answer that question, do they build it best? So you need to understand that problem and how we talked about it. So do we build it best really had a lot more meaning packed into that question. Are they as efficient as possible? Okay, and what does that mean? Efficiency in this case is, can they store the most honey for the least amount of wax that they use to build their honeycombs? That's essentially the question that we're being asked to solve. So you need to be able to explain that. There'll be some type of a question that will ask you that. You want to explain how we solved it. What did we explore? What did we do along the way? The basics of that are, we took a look at surface area and volume for right prisms. We developed the need to do that through several exercises. We explored different things, and we came up with this approach. We're looking at these two quantities, surface area and volume for right prisms. And a lot of the activities we did had you explore how to find volume, how to find surface area. We did problems with scale factors between rectangular boxes, things like that. We also explored regular polygons. You need to know what that is. And we talked about tessellation. And these were also things that we needed to solve the unit problem. So you want to dig back in your notes, look over your exercises, talk to folks in the class with you, look over old quizzes, things like that, and get yourself around the unit problem. Not only will there be direct questions that will ask you things about this, but there will also be other questions on the test that have you do some of the mathematical operations that we did along the way to solving the unit problem. So in the beginning of the unit and with the POW, we used Geo Boards to figure out and explore area of polygons. And a polygon is just a many-sided figure. So triangle, square, octagon, hexagon, all those things are polygons. Even weird shapes like that one, that's a polygon, many-sided. And what we did with the Geo Board is we used the pegs, I'll get closer here, we used the pegs and we used one square as a unit of area, and we came up with techniques for figuring out what the area of, say, this polygon might be on a Geo Board. So we did a lot of different exercises with that. We worked through triangles with certain heights, certain areas. We used the Geo Board activities to figure out the formula for the area of a triangle, things like that. So you're going to want to be familiar with that. You will see some Geo Board-based questions on the test. And finding the area of any polygon, that would be one. So I could put this one on there if you like, or if I like. You could also be asked to make a polygon with a certain area. So I might say, show me 5 triangles that have an area of 1 on a Geo Board. And then you'd have a blank Geo Board and you have to sketch those triangles on there. And we did some exercises like that. You also had a quiz with questions like that. Okay, we also spent some time looking at the Pythagorean Theorem. So pause the video for a sec. What is the Pythagorean Theorem? Write it out. Okay, if you wrote this, a squared plus b squared equals c squared, you're right. So now I want you to pause the video and draw a triangle with those letters on it. Okay, let's see how you did. I'm going to draw my triangle like this. I'm going to mark my angle, and my A and my B are the 2 sides that are next to the right angle. Doesn't matter which one, I could switch them. But C is the hypotenuse, it's the side across from the right angle. Okay, so here's the formula, here's the diagram. And remember, diagrams are often essential in geometry because it's a visual thing. We have visual figures that you look at. Okay, where can you use it? Kind of already given you that answer to that question. You have to have a right triangle. If your triangle doesn't have a 90-degree angle, don't use the Pythagorean Theorem. You can't use it there. Okay? So that's an essential part. How can you use it? It's pretty straightforward. I might tell you something like A is 3, that side is 3, b is 4, and then you plug that into the Pythagorean theorem and you solve for c. So you're going to have to square some things and take some square roots along the way to do that. Word problems. So you might see a word problem or two that requires the Pythagorean theorem to solve. Now it might say, or it might give you a hint, that the Pythagorean theorem might help you there, but it might not. So you're going to have to analyze the situation, look at it. There'll be a triangle somewhere in there with a 90-degree angle, and then that will be your clue as to where to plug in the information that you have to find the information that you need to find. In this unit, we also did a fair amount of trigonometry. So what is trigonometry? You remember SOHCAHTOA? This is the key tool to remember what each of the trigonometry functions are. So SOHCAHTOA. So I'll go through this. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So there's a condition that you need for this. What is that? If you thought right triangles, you're right. So I'm going to draw a picture up here. Marked my angle. Now, or marked my 90-degree angle. Now I'm going to pick an angle in here and we'll call it theta. Remember, theta is just a variable that we use for angles, like we use x as a variable for numbers in an equation. Theta is a variable for angle. And I'm just going to do one quick problem so you can see how this works. What if I tell you that this side is 5 and I want to find this side? Okay? So we can use one of these three trigonometric ratios to write an equation that we can then solve and find the value of x. So if you think you know what to do right now, pause the video and put that together, work the problem, and find x. I had to go get my handy-dandy calculator because you have to have a calculator to do these problems. Put that right there so it's ready to go. Okay, so the trick here, put yourself in the angle that you have. Actually, there's something missing. I need to tell you one thing more to be able to use trigonometry to find x. What is that thing? If you thought, I need to know what theta is, you're right. So I'm just going to tell you, theta equals 32 degrees. Okay, so now we're ready to put this in a trigonometric equation. Here's the angle I know. Here's the side I know. Here's the side I want. So they relate together. Theta is here. 5 is opposite of theta, and x is the hypotenuse. So x is always going to be, the side across from the 90 degrees is always going to be the hypotenuse, and then the opposite and adjacent depend on which angle you have. So for theta here, the 5 is the opposite, whatever this side is would be the adjacent. Okay, so I have opposite, I need hypotenuse. So now I need to figure out which of these three functions will help me with that. And this is kind of nice because it's the first one. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I have hypotenuse, it's part of my thing, but I don't have the adjacent. And tangent is opposite over adjacent, so that's not going to help us here because we know the opposite and we want the hypotenuse. So what we write is sine 32 equals opposite over hypotenuse. Now I have a little trick to help memorize what to do with this equation before you start punching in the calculator. When the variable's down low, you switch, you know. So the x comes up here for sine 32, and sine 32 goes down where the x was. So this becomes x equals 5 divided by sine 32. And I strongly recommend that you do it this way before you get out your calculator and find out what sine 32 is. Because this is super simple. On my calculator, all I've got to do is let's clear it out, do 5 divided by sine 32, press equals, and I get my answer, 9.44. Okay? So we did trigonometry in a couple different problems, and then we also used trigonometry when we were finding the area of these rectangular polygons. Remember, Rancher Gonzalez had 300 feet of fence and wanted to make a corral out of that held the most area. And to calculate the area, that calculation we did, which is probably the biggest, most complicated calculation we did in the unit, we used the tangent function to do that. Okay, the most complicated calculation we did in this unit was one of these, the corral area calculation. And how it worked was you were given a perimeter and you were asked to find area. And there was one other condition, that the thing that you were finding the area for was a regular polygon. And a regular polygon is a polygon that has all the angles the same and all the sides the same length. So it's a hexagon, octagon can be regular, all those things. It needs to be regular so that you can do the math that we're going to do. I'm going to set that up on this diagram, but I'm not going to finish it. You did this calculation probably 5 or 6 times in class. We did various numbers of sides. So you should drill back in there, take a look at those calcs, and then test yourself. Put your previous work aside and just do another one and see if you can get the same answer you got the last time. Okay, so the setup was this. If the perimeter is 300, then each side of the 6-sided figure, it's a regular polygon, is going to be 300 divided by 6, which is going to be 50. So in this case, each side is 50. So we could mark that all the way around. So that was kind of one of our setup steps. And then we also know something about the angles. If I go to the center and I start drawing lines out, there's 360 degrees to go all the way around. And we have how many angles? 1, 2, 3, 4, 5. We have 5 angles, so that's going to be 360 divided by 5, which gives us 72. So 72 degrees in each one of these. Then what we did is the process was, if we could calculate the area of one of these triangles, then really there's just 6 of them going around. So if we find that area, we can just multiply it by 6, in this case, to get the area of the whole hexagon. So to do that, what we did is we dropped a vertical down from the center, and we made a right angle there. And then if this whole angle is 72, then the little half angle in there would be 36. And then if this whole side is 50, we know that side is 25. So from here out, what we did is we used trigonometry to find h, which that's our height of our triangle. And then once we knew the height, we used the area formula for a triangle to calculate the area of that particular triangle. And then we multiplied it by the number of triangles in the figure to get the total area. Now, I'm aware, I'm not doing this problem, I'm just setting it up, because I want you to dig into that problem, look over your old work, and then try it again. And of course, we have a couple classes between now and our unit test, so bug me about it. Ask questions of your group mates or anybody else in the class, because I promise you, this calculation is on the test. We also spent time analyzing cereal boxes. There were, I think, 4 different activities where we played around with cereal boxes. And the main thing there was that we were exploring the volume that the box would hold and the surface area of the outside of the box. And so with cereal boxes, we had some pretty simple formulas for volume and for surface area. You'll want to know those. You want to have those on your cheat sheet. And then what we did is, what made this one a little tough was we took a situation where we had a cereal box, like perhaps this one, with length, width, and height. Those are our dimensions. And then we compared this cereal box to a bigger one that had maybe double the dimensions. So let's say that this one would be twice the height, twice the length, and twice the width of this one. And so we played around with how doubling the dimensions of the box affects the surface area of the box and affects the volume of the box, because it's a little bit interesting how that works. So first off, you just need to be able to calculate surface area and volume, and then we played with scale factors. So let's review the scale factor thing just a little bit. Okay, I'm going to go ahead and put some notes on here. If this box is twice that box, then the height here would be 2h, this would be 2l, and this would be 2w. So whatever that is, if this is 10 inches high, this would be 20 inches high, and so on. So in this case, the scale factor between these two boxes is 2. We just multiply the height of the old one, the width of the old one, the length of the old one by 2 to get the new dimensions of the box. So scale factor, I'm going to say it this way. If the scale factor is 2, and I'm just going to say SF for scale factor equals 2. So the way we use the scale factor is it lets us go back and forth between surface area and volume for the two boxes without having to actually do the calculation. So the trick to remember here is that if the scale factor is 2, then the old surface area, I'm going to abbreviate surf area, the old surface area gets multiplied by the scale factor squared. Okay? Because area is a squared quantity, so you square the scale factor, so this would be times 4, and that's going to give you the new surface area. Okay? So if you calculated the old surface area, and you knew the box had, the scale factor was 2, we doubled the dimensions, then you would multiply the old surface area by the scale factor squared, which would be 4, to get the new surface area. So you can skip the calculation just by using the scale factor. It's the same with the volume. Old volume times the scale factor, but this time it's cubed, which would be 8, equals the new. And that makes sense too, because volume is a cubic quantity. It's cubic somethings, cubic inches, cubic feet, things like that. So you've got to cube the scale factor, multiply that by the old volume to get the new volume. So that's how you use scale factors. We spent quite a bit of time in class going over that. You want to look at your notes. I guarantee you will get a problem that's going to ask you to navigate this. Okay, one of the last calculations that we did in the end of the unit is we looked at these two concepts of lateral surface area. This is not total surface area. This is lateral surface area and volume. Okay, so let's talk about what lateral surface area is. I've drawn a hexagonal prism, okay? And so I have my prismatic base, or my hexagonal top and my hexagonal base back down. You can't quite see it all, but it's there. And then I have my lateral faces as I go around the prism. So the lateral surface area is just the area of the lateral faces. So it's the area that doesn't include the bases, okay? So that's the LSA. And we had, the LSA is just the perimeter times the height. That's all that is. Then we did volume of prisms. And we had a special formula for that. That's just the area of the base times the height. So area, base, times height. And that's how we could get the volume of the prism. And I guarantee you there will be some problems that will have you do these calculations on the test. Okay, I want to call your attention to the review sheet. I've published this on our weekly planner, and it's got a bunch of stuff on it. I just went through these main bullet points. These are the topics that are on the test. And also on here, you'll see references to page numbers in our book where you can look up the activities that will help you review these topics. And this is one of the reasons why I encourage you to always write the page number on your homework so you can flip back through your book and you know what you're looking at. Okay? So we just went through all of that. There's also a little blurb on cheat sheets on the bottom. You want to read that over. Basically, it's two sides of one regular size sheet of paper written in your own hand. Can't be pasted, copied, typed on a word processor. It has to be written by your own hand, but you can put anything you want on there. On the back, we've got a vocabulary list. So you want to read through all those terms and make sure you know what they mean. If you don't, you may miss a multiple choice question that just hinges on that definition, or you may do the wrong thing on a word problem because you misunderstand one of these keywords. So go through that list and make sure you understand. I bet you understand all or most because it has been our vocabulary for this whole unit, but it's a good idea to check. I've got a bunch of study tests, a bunch of study tips there. So read through that, use the tips that apply to you, but there is one super important one that I always like to remind people. Get enough sleep the night before the test, and make sure you eat breakfast that morning. Your body needs rest and fuel, and your brain is part of your body. So you've got to take care of your brain if you want to do well on the test. Lastly, some people are going to like this. Here is a formula table. This table is going to be on the test. So as you study, as you prepare your cheat sheet, you can look this over, and if you see it there and you like it the way it is, then you don't need to put that on your cheat sheet. Here's something not to do. Don't assume this is everything that you need to earn your best grade. Make sure to do a cheat sheet. Just know that this is there for you on the test. Okay, so that ends this review video. I wish you the best of luck. Show me what you got. One more thing. Bet you thought you were done, right? No, I got one more thing. It's quick. Make sure that you do the review assignment. I'm giving you quite a bit of time to work through that. There's a lot of problems on there, but the best way to earn the most points doing problems on a test is to do practice problems before the test. So the review assignment is designed to get you practicing all the things that you're going to need to do well on the test. So don't forget that part. Make sure you do that. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that didn't go in so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.